Here is a uniform distribution problem. So how do you know that a problem is uniform distribution problem? The answer is the problem will tell you, the problem will state uniform distribution in the problem statement. All right. So this is about waiting time during office hour. The waiting time is the difference between the time you arrive at a professor's office and the time you are invited into the office. So the waiting time of a math professor's office hour is between 0 and 20 minutes. And then the time follows uniform distribution. So the last two sentences, that's all I need to know. So in a uniform distribution problem, the first thing that you have to point out is the lower limit. So A is equals to 0 and B is equals to 20. And that follows uniform distribution. So how do you set up the probability density function? The PDF, probability density function. So that is f of x equals to 1 divided by the maximum minus minimum, which is 20 minus 0. That is 1 over 20. And then the domain means that x lives between 0 and 20. So this one, other than this, I want you to sketch a graph. So let's sketch a graph. Let me make the pen smaller. Sketch a graph. So here is what we have to do. This is a vertical axis, horizontal axis, and then we are from 0 to 20. So at 0, we have a point. At 20, we have a point. And then 1 over 20 is y equals to 1 over 20 is a constant function, right? So it's a horizontal line. The slope is equals to 0. So we draw a horizontal line. So the cut is between 0 and 20. So we cut that right here. And then the height of the rectangle that looks like a rectangle, right? What's the height? The height is just the PDF. And then, so remember this, back to the discrete random variable, we have a table that is the probability distribution, right? What is the sum of all the probability? The sum of all the probabilities equals to 1. And then x has a few distinct outcomes, right? Countable number of distinct outcomes. So in this one, the x is a continuous random variable. We are not able to give you a number of distinct outcomes. So the probability is all about area. So back to the distribution table, the sum of all the probabilities equals to 1. In these problems, we can only show that the area of this rectangle is equals to 1. So the area of a rectangle is base times height. So the base is 20 minus 0. That is the length of the base. The height is the PDF times 1 over 20. That equals to 1. So we just prove that this area is equals to 1. So that is the setup of the problem. You have to pay attention to this. If this is wrong, the entire problem is wrong. All right. So I wrote a few problems for you. So let's do this. B is calculate the expected value, variance, and standard deviation. So for part B, the expected value, the EX, we have a set of formula for for uniform distribution only. So the expected value is 1/2 times A plus B. So which is 1/2 times 0 plus 20, that equals to 10 minutes. This is in minutes. So that means on average, you have to wait 10 minutes in order to go into the office. And then the variance is 1 over 12. This 1 over 12 is always 1 over 12 is built in the formula times B minus A squared, always 1 over 12. All right. So 1 over 12, 20 minus 0 square. So this one is around 33.3. The unit is minute square, because the 20 minus 0 you square the difference. That means you square the unit as well. And then standard deviation is the square root of 33.3, which is 5.57. So on average, you have to wait 10 minutes to give you a better estimate. You have to plus or minus 5.57 to set up an interval estimate. So interval estimate is always more flexible compared to a point estimate. So let's say I ask you a question: how much time do you need to drive to school? You don't say I need 20 minutes, right? You say on average I need around 15 to 30 minutes to drive to school. So the 20 is a point estimate. You are using one number to estimate another number. The 15 comma 30 is an interval estimate. You want to make your answer more flexible. So if you are applying a job, I won't say I pay you exactly $20 per hour. I don't say that in the job description. I will say that on average, I pay $15 to $30 depending on your experience, because I want to make myself flexible. All right, so that's the reason of using an interval. So the next problem is C. Find the probability that the waiting time is between 10 and 15. So C is probability 10 less than or equal to x less than or equal to 15. By the way, is the equal important? The answer is no, because x is a continuous random variable. So this, I recommend you to draw a graph. So I already prepare a graph for myself. So the graph I have is like right here. So I should make the graph smaller. And then I copy that for my next problem. So 10 to 15. So 10 is like right here. Okay, I should go back to my pen. 10 to 15. And then between them, then you have this area. So this is the probability that we are looking for. So tell me, how do you find the area of a rectangle? Easy. You have the base, which is a big number minus small number. You don't want to use small minus big, because area probability cannot be negative, always big minus small. And then you times the height of the rectangle, which is the PDF. So this is 5 divided by 20, or a quarter, right? Or you can approximate that to 0.25. Okay, so part D is at most means no more than 3 minutes. So D, we have probability that x is no at most, so that is less than or equal to 3 minutes. Oh, is this important? I haven't answered that question yet. The answer is not important, because x is a continuous random variable. All right, so this one I am going to do the magic. I am going to paste the graph right here for me to use, and then 3 is here, and then less than or equal to 3. You don't need to make a perfect scale. So that is my probability, and then that is 3 minus 0 times 1 over 20. So that is 3 divided by 20. So that is your answer. You can approximate that. So if you take 3 divided by 20, that is equals to 0.15. Do you really need to put your answer in decimal? You have to read the problem. All right, the next part is this is D. The next one is E. E is at least 12 minutes. Oh, by the way, if you don't want to keep going back to the video, I suggest you to take a screenshot right now, so you have all the problems comes in handy. All right, take a screenshot. Done? Okay, now we go to E. So E, at least, that is x greater than or equal to 12. Actually, the equal is not important, because x is a continuous random variable. So time to bring the graph up, and then we have 12. So suppose this is a 12, and then this is the area that I am looking for. So we have a big minus small times the PDF. So that is 8 divided by 20. Then that is your answer. Easy, right? Easy math. And then F and G, they are not so easy. They are conditional probability. You have to take one more action when it comes to conditional probability. So here is what I wrote for F. Given that a student has been waiting for 3 minutes but is not yet invited into the office, what is the probability that the student will be invited into the office in the next 10 minutes? So first of all, you are at 3, you spend 10 more minutes, so the maximum is 13, right? So let me bring my graph back. So we need to make a little modification in this graph. First, let's get the probability notation done. Okay, don't jump any step, just follow me closely. So this one probability given that x is greater than or equal to 3. How come that is greater than or equal to, not less than? Because you are starting at 3, you are still waiting, right? So at 3, you are right here, and then you are still waiting. And then you start at 13, so 13 is right here, so 13 is right there. So that at 13, you will be invited into the office, right? So between 3 and 13, during this time window, what is the probability that you will be invited? So that means we are looking for the area of this box, right? So easy. It looks like it's 13 minus 3 times 1 over 20, and then we are done. No, it is not so easy when it comes to conditional probability. Let me go ahead and finish my writing. So what do we have to do? Let me change colors for this because this is way too important when it comes to conditional probability. You have to change the probability density function. So since the given is greater than or equal to 3, the PDF is now the maximum, which is the given maximum, minus the minimum. The minimum is no longer 0. The minimum is 3 now. All right, it's 3 now. So that is 1 over 17. If that is a 5, you have been waiting for 5 minutes, then that will be a 20 minus 5. Okay, so here is the trick. So 1 over 17, then this is no longer accurate, then this is 1 over 17 now. All right, so let's go back to the problem. So to answer find the area of the box, we have 13 minus 3, that is the base, but the height is no longer 1 over 20, it's 1 over 17. So my probability is 10 divided by 17. So that's how you answer a probability question. Okay, the next one is G. So you have the screenshot, right? You have the problem. I am not going to go back up to the problem. So G is, suppose a student knows that he or she needs to wait at least 5 minutes to be invited into the office. What is the probability that the student has to wait at least 16 minutes in order to be invited into the office? Step 1, get the probability notation done. So given x is greater than or equal to 5, right? At 5, you are still waiting. And then at least 16, at least means 16 or above. So x greater than or equal to 16. This one makes the graph very interesting. So let me bring the graph back. So I know that this is a conditional probability. The 1 over 20 needs to be changed, right? Okay, so we change color and then we do the modification. So this is a 5, right? And then this is a 16. Oops, not between 5 and 16 anymore. Greater than or equal to 16. So this is the area that we are looking for. How do we change the PDF? The PDF is f of x equals to what? 20 minus 16? Nope. 20 minus 5. Always minus the given. Again, always the maximum subtract the given. Again, always the maximum minus the given. Again, maximum minus given. You got me, right? Minus 5, so that is 1 over 15, and then we modify this to 1 over 15. So we turn to the problem. We have 20 minus 16, that is the base of the rectangle or square, whatever you like to call, times 1 over 15, so that is 4 divided by 15. Now the job is done. So that is the end of part G. And then I have 2 more parts for you because I can't predict the amount of space I need to show my work. So for H and I will just read the problem to you. So you don't have the problem. You don't have to go back to the video. The problem is not there. All right. So I will just tell you what the problem is. So in the next part H, what I am looking for is I am looking for the upper 27.8 percentile. Upper. What is upper? So we draw the graph one more time. So allow me to just paste the graph so I can save a little bit of time. So what is upper 27.8? Upper means right side. So upper is right here. This is a 27.8%. I want you to tell me where to cut the graph to have 27.8% on the right side. So tell me, how do you get the probability? To get the probability, you have maximum minus the minimum and then times the height equals to probability, right? 278. That's how you convert from a percent to a decimal. So this one, you have to solve for k. So to solve for k, first you multiply 20 on both sides. So that is 0.278 times 20. And then you can do 20 minus the product equals to k. Just a very simple equation. Okay, in case you can process this, so let me do a little note for you. So let's say we have a 10 minus x equals to 2. How do you solve for x? X is equals to 10 minus 2, which is 8, right? That's how we solve this equation. All right, and then you use your calculator. So you have 20 minus 0.278 times 20. So k is equals to 14.44. So 14.44. So the probability that a student will be invited into the office between 14.44 and 20 minutes is 27.8%. So the time window is from 0 to 20, right? So let's say you start at 14.44 and then you end at 20th. What is the probability that you will be getting to the office? 27.8%. And then the last part is part I. I asked for the lower 30.9 percentile. 30.9 percentile. Actually, I don't need to use this word because 30.9 percentile by itself means left side. So back to the box plot problem. By the time you get into a uniform distribution, you must have learned what box plot is. Still remember Q1, the first quartile, right? So that is the first 25% of the data. So percentile means the first 30.9 if you just interpret this word alone. Without the word upper, if I just give you one word, percentile, that means left side. All right, so we paste the picture one more time to save me a little bit of time, and then we cut 30.9% on the left. Without the word upper, is always the left, and then this is the quantity that I am looking for. So I have k minus 0 times 1 over 20 equals to 0.309. So k minus 0 is k, and then you multiply 20 on both sides. So 309 times 20. So what is k equals to? 0.309 times 20. So that is equal to 6.18. This is in minutes, so that is 6.18. So if you start at the beginning and then you wait 6.18 minutes, the probability that you will be able to get into the office is 30.9%. So that is the end of this problem. I will see you all in the next video.